Okay.
For what?
5-2 day 1. Okay, the last time we were here, we talked about the empirical rule. If for normally distributed data, just real quick, let's review the empirical rule. For normally distributed data, normally means this nice symmetrical distribution. We found the percentage of the data that was within 1, 2, and 3 standard deviations away. Do you remember the percent that's exactly 1 standard deviation away?
34%.
Each side was 34%. We had 68% between these two. Nice job remembering that.
But I just took the notes, so I didn't.
Oh, that's why. What was the percentage for 2 standard deviations away?
90-something.
Yep, 95. So all 4 of those made 95%. And then the 3rd standard deviation out.
What is the little circle with the tail?
Standard deviation.
Oh my God.
99.7%. Only 0.3% of your data was within the tails of the graph. What we're going to do today is find the percentage of the graph that doesn't land exactly on 1, 2, and 3 standard deviations away. So we're going to be in between these things. So that's where we're headed. And what we're going to be doing is converting scores into what's called a z-score. So a z-score, something under my, a z-score represents
We're like, yeah, behind.
the number of standard deviations away from the mean.
Wait, hold on.
Okay, I'll wait.
I can't write anymore.
All right. So what we're going to be doing here in a minute is converting a data value into a z-score. You're going to be able to tell me how many standard deviations away from the mean a particular number is. It's a simple formula. Subtract and divide. Are you ready? Oh, come on. I feel weak. Okay. Okay. The z-score for an x value. What you're going to do is take that x value, subtract the mean, and divide by the standard deviation. That's the formula you're going to use. Subtract and divide.
Not too bad.
Here it is. So, we've got some utility bills. This is real. Are normally distributed. With a mean bill of $70 and standard deviation $8. And then we are going to sketch the graph and then find the z-score for a $60 utility bill and a $73 utility bill. I'm not really doing anything but writing yet. I'm going to wait. That's just the... I don't know. I did pretty good first hour, too. Usually I'm bad. And you guys are in your third class. It should be coming back to you by now.
I didn't do anything my first two classes. My first two classes.
Oh, nothing? How do you do nothing?
I painted.
Oh, art. Well, that's something.
English first hour.
No. You didn't read anything there?
Chores, I don't have to write.
No.
So really, this is the first class.
Okay, are you ready for the graph?
No.
No? What, do you wait for me to finish before you start?
I can't do this. I can't do this ever.
Okay, I know the utility bills are normally distributed with a mean of $70. That's the middle. Remember, the mean shows up in the middle. And then the standard deviation is $8. That means exactly one standard deviation above the mean. I just add the 8 on, that's 78. 2 standard deviations above the mean, what's 8 more added onto that? 86. And then one more.
Is that 173?
8. I'm adding 8. And then 94. Now we'll back up the 3 standard deviations. So subtract 8. That's 62. Subtract 8 again. That's 54. And 8 more.
46.
46. Very good. Okay. So this 78 is 1 standard deviation above the mean. 86 is 2 standard deviations above the mean. And then 3 standard deviations above the mean. Now what I'm asking you is $60. How many standard deviations away from the mean is $60? Well, you can see it's right about here. So it's less than 1 standard deviation below the mean. We want to know exactly how many standard deviations. So it's a partial. What? You found the other side? Oh, it is on the other. Oops.
No, just leave it. Just use the right line now.
Oh, yeah. This is my 62. Yep. There you go. That'll work. It's right there. It's more than 1 standard deviation below the mean. Let's see how far below the mean it is. We're going to use this little formula. The z-score for $60. The formula says take that x value of 60, subtract the mean. What's the mean for this problem? 70. And then we'll divide by the standard deviation, which is 8. So what is negative 10
Wait, why did you get the 8 on
divided by 8? What's negative 10 divided by 8?
Negative
1.
over
Negative 1.2.
Negative 1.25.
negative
It's a calculator problem. Don't worry if you can't. So what that's telling me is it's 1.25 standard deviations below the mean. So we're not going to be landing right on 1, 2, and 3. We're going to be in between.
Why did you tell us? What was the line? What does the line have to do with anything?
What?
Why do we need the picture?
Yeah.
Oh, just to show you what we're finding.
Okay.
Okay, the z-score for $73. This time I'm going to get it in the right spot. That one's just above the mean. Less than 1 standard deviation above the mean. How far above the mean is that? How many standard? It's a partial. Let's figure it out. 73.
Was the other one not a partial?
Yep. 1.25 minus 70. Divide by 8. This time it's going to come out positive because I'm above the mean. So negatives are below the mean, positives are above the mean. So we're going to get 3/8. What's 3/8 as a decimal? They do all decimals on these.
0.375.
0.375 standard deviations above the mean. So not even one full standard deviation above the mean.
It's gonna get a lot harder, isn't it?
Not much. It's not bad if you stay with it,
Okay.
truly. Okay, are you good here? You can turn numbers into z-scores. Know that this is a z-score, and the z-score tells you how many standard deviations away from the mean.
Will the problems be that straightforward?
Yes,
AM,
they can't, they have to give you the mean of standard deviation. There's no other way to do it.
Okay.
Okay. All right, let's call this part A, because we're going to do a...
Cannot do that for me. Oh my. Wait, I don't even remember what. Random little. It was really.
Yep. Because I want to use the same data. All right, B.
It doesn't always sound like that. That one. Really good. They're laughing like.
Both the same as the last one.
I figured we'd have to do this.
What occupation does these scores?
Okay. Okay, what is the bill that has a z-score of 2.25 and a z-score of negative 1.82? So if I just look back at the graph for a minute, once you get that written down, I know the z-score, but I don't know what the amount of the bill is. That's what we're kind of just going to reverse our formula here. So take a look. The one that's the bill that's 2.25 above the mean. Well, this was 1, 2, it's somewhere up in here. So it's it's above $86, but less than $94. I want to be able to find that. And we're going to use the exact same formula we just had. The z-score equals the x value minus the mean divided by the standard deviation. Well, this time I know the z-score, I still know the mean and standard deviation, I can solve for the x. So it's just an algebra problem. So we'll go with the 2.25 first. That is the z-score. I don't know the x. I know the mean is 70, and the standard deviation is 8. So what are my two algebra steps that I need to do to solve this for x? Multiply by 8, times by the 8, times by the 8. Not that I can do that in my head. 18. And now add 70. So $88 is the bill that goes with that z-score. Okay, not very challenging, is it? No. Let's just simplify this formula. Let's rewrite it. You told me the two steps. It was multiply by the standard deviation and add the mean.
Why do we have to make it complicated?
Well, actually, I'm not trying to make it easier.
How could it get easier than this?
Well, if you just put it in the right form right off the bat to solve for the x, you're good to go. That's what we just did. So the z-score we're doing now is negative 1.82. That's almost 2 standard deviations below the mean, just shy of it. Multiply by that $8 standard deviation, add on the $70 mean. Now it's just one line of work.
What are you doing? I don't.
I'm doing the exact same thing I just did here. This thing that took me 1, 2, 3, 4 lines, I just did in 2 lines. It was 2 steps. We multiplied by the standard deviation and added the mean.
Why?
To show you where it comes from. It's okay. I would put this on my note card.
I need a mail file.
So what is this coming out to be? Anybody with a calculator?
That Casey, come on.
What?
Flashing.
Oh, I don't know if she has the answer. It's
Yeah.
55.44.
What 544?
55.
55.
I got this
44.
jelly beans, okay?
Who we got out there?
John.
Why is this different?
Hello. That's okay.
Really quick, do you have an extra teacher geography class?
I can look for one. I don't know that I do. I will look for one.
Could you just like throw it on the bus?
Yep, I will do that right after I'm done here. Yep, yep.
Short's negative.
Why, she just threw the formula.
Short's negative.
I just moved the formula
Why
around.
is it different?
Because I did this one.
Sweet mother of God.
Short's negative.
Okay.
Okay.
Where?
Short's negative.
No, no, it's a bill.
Why?
$55. It's the Z-score was negative because the $55 is down here. It's below the mean.
Yeah,
But the bill is not a negative $55.
why do we put it?
Well, that's what it is. I want to know what Z-score, when I say negative 1.82 is the Z-score,
No, I
that,
get that.
okay.
Why are we putting that into the formula then? Why don't we just put 1.82?
1.82 would mean the one that's above the standard deviation by almost 2. This one over here.
Put in the calculator, does it come out the same?
Nope.
Negative 1.82 times something is 0.82 times something?
Nope. You want to do exactly what you have here. Negative 1.8. If it's negative, keep it negative. Don't change it.
I can't talk.
Okay.
God, Kate. God, I do break off all the time.
Of course, what else could we possibly do with this?
Right now,
Hey. Check yourself, Kevin. I'm gonna check myself. And then they'll move.
okay. We're going to take those 7 values from example 1 that are on that graph and convert them into Z-scores.
Sounds like fun.
Super easy. You had the 70, the 78, 86, and 94. And then the 3 below.
George, just give us a second.
Yep, I'm just going to write them down. 62, 54. I'm not doing anything new. 46.
Yeah, I don't know.
I'm just writing down the same thing I wrote down on number 1. You don't need me to go slow.
Yeah, hold on.
Okay, now I can wait.
Thank you. Here we go. Jeez. Wish I really missed you.
Oh, you lie.
You lie.
Irish. I know.
I'm sure you didn't think about our stats one time on vacation.
I did. I was actually stressed about it because I'm leaving again this week.
I
Oh.
don't remember.
I didn't. I wasn't so much thinking about that. I was thinking about you.
Oh,
Aw.
she's still lying.
She just wants a better grade. Right. I don't need a better grade. I'm already accepted into college. Yeah. I saw you laugh in line when you announced our niece's graduation. I'm afraid of that.
Okay, what I'm asking you to do here is very
Like, I'll step over.
easy. Think about it, okay? I'm talking. I'm asking you to convert these 7 numbers into Z-scores. Guys, zip it. All 7 of them. So think about the 70. How far away from the mean is 70?
Zero. This is
0. The mean has a Z-score of 0.
Okay.
How far away is 78 in terms of how many standard deviations away is it?
8.
One.
Why
How many standard deviations away is it?
One.
It's 1 away, because the standard deviation is 8. So 78 is 1 standard deviation above the mean.
And then would it just be 2
And then it would be 2,
and 3?
and then 3.
And then it's negative on the other side?
Negative 1, negative 2, and negative 3.
Wow.
So that's how many standard deviations away. Each $8 is a standard deviation. So, what you just did by converting all of those to the Z-scores, that's called the standard normal distribution. So definition. The.
So is this a part of the example?
Nope. Definition. Standard normal.
Is example 2 like an example of the standard normal?
Yes, it was creating the standard normal.
Okay, so I should fit that in my.
The standard normal distribution has a mean equal to 0 and standard deviation equal to 1. And every normally distributed group of data can get converted into this, and it'll look exactly the same. The mean will be 0, standard deviation will be 1. That's called the standard normal distribution, as opposed to a normally distributed group of data. Okay, the last thing we're doing today is we're going to be finding areas on the standard normal, and we're going to do it two ways, with a table and with a calculator. Like I said, the whole semester we're going back and forth between like by hand stuff and calculator stuff. Well, we're going to find out here in a minute. Okay, put that to the side. Yep, that was it. So now, finding area Okay, first thing we're going to do is learn how to find the area under the curve by table, and then I'll show you the calculator. That's the last thing we're doing today. Okay, your standard normal table, it's in two places in your book. It's on the front cover. If you look inside the front cover, you'll see this table here. And it's on the cover and then it's 2 pages. Okay, so you need your book out to read this.
Are these like bullets or what?
Nope, I'm just going to explaining the table. The table gives the area to the left of the z-score that you look up. See how at the top they show you the area, they've got it shaded, and it's the area to the left of a z-score? Right here, I'm talking about this little picture right here. They've got the area shaded behind the z-score that you're going to look up. Yes?
How is -0?
Okay.
How is it -0?
Well, because we got the tenths places up here. I'll explain it. So. Patience, patience, patience. Okay, so here we go. Is this example 3? Okay. Find the area let's go left of a z-score equal to -1.63. So I'm just going to do a quick little sketch of what we're finding. Remember, a z-score of 0 is in the middle. -1.63 is about here. I'm just going to estimate it. and I want the area to the left. Yes, draw this. It will make more sense if you take the time to draw the pictures. Everybody ready to read their table? Okay, take your table. Your negative z-scores are on the left-hand side. I want negative 1.63. So I'm going to find negative 1.6 right here. And if you look across the top, they've got the numbers that are in the hundredths place. And I want it to be the 0.03. See how that works?
0.0516.
And if I go down, only a little over 5% of the graph is shaded to the left, 0.0516.
Where'd the 0.03 come from? How do you do that?
I asked for 1.63. See how the 3 is over in the hundredths place? Because that top row is giving you the number that's over here in the hundredths place. Does that make sense or not?
Yeah.
So what was it? 0516.
16.
Okay, try another one.
Do I need to draw that out now?
Left of z equals 2.08. That's a positive 2.08.
Wait, do we go to the right?
So now, yep, you're going to go on the right-hand page. 2.08. So here's the 2.0. And then you want to look at the top for the 0.08. What do we got? 9812. Okay. Okay, ready to switch it up?
Yep. Okay.
To the right of 1.15. Okay, so I can change it up just a touch. .15 is about here. I'm looking for this area. Okay, the table will only give me the area to the left. But what do I know about the total area under the curve? It adds up to 1. So what am I going to do if I know the area to the left?
Subtract.
From 1.
No, oh my god.
So it's going to be 1 minus what you look up in the table.
I hate this.
1 minus the table value.
Could you explain that to me?
Because the total area under the curve is 1.
Okay,
So these two pieces add up to 1.
okay.
When I look up this number in the table, it's going to give me this back here.
Okay, I get it.
Okay.
Okay, so you put that in something.
So 1.15. What is 1.15? Positive 1.1. 0.8749. And then 1 minus that is giving us...
0.1251.
Okay, I'm actually going to save the calculator part for tomorrow. I'm going to call it good.
Oh, very safe.
Yeah, we're going to quit there. Let's see. Get to the right week here. I'm going to make sure, because I didn't quite get to everything, I don't think. 5-2.
Thanks, Kate.
1 through 4.
Super failed. I mean, not we, you failed. Okay. I say super failed, okay? Like, I just don't, like, it's not, okay, like, do like you failed. You failed.
Let's see, we're going to go with, because I didn't do all of it, page 209.
One through 10.
No, I'm going to go, where's the converting at here? 6,
Personal pay, this is.
A. Yep.
Yeah. Six months gap when I ran into I'll pick. I can't pull my hands up that high either.
21 to 28.
Oh, I love you, Miss Short.
You're welcome.
Okay.
All right, that's good. Yep, okay.
Yep.
We're done there.
Yep, we're done.
Your estate, you did not. Thank you. I was only.
Okay. Yep.
Somebody's strong,